welcome to the Rudder room. So we'll start with the first talk that will be kind of an introduction to Rudder through practical examples. So we'll see how to actually configure things and automate things and audit things using Rudder. So we'll start with a brief introduction. So Rudder basically does configuration management, so that's why we are here, basically. But configuring things is automating configuration is good, but we still need some other features for production management day to day, and so that's what we focus on. But everything is built on configuration management abilities. So Rudder allows configuring systems, auditing configuration of systems, maintaining security policies or guidelines, and providing comprehensive compliance reports to the users. So how does it work in practice? Well, we have a central server that will contain all the configuration we want to apply to the machines in a Git repository, actually, and a database of managed machines and of reports about what happened on the machines. And then we have an agent installed on all managed nodes that will execute the policies and report about it, basically. So that's the main architecture. So here you have the central server that has all these data stores and that can compute the policy we need to apply to the different nodes. And then the nodes will download the policies, apply them, and report about it to the users. And to configure the policies, we actually have a full web interface that allows everything from defining the policies you want to apply to having an overview of the current status of the infrastructure. We also have a full API. So our goal for the demonstration today will be to install an OS query daemon on all our nodes. So we'll have a demo platform and we'll try to install it on all the nodes. We want to ensure configuration complies with CIS guidelines for a CentOS 7 system. And we'll see how we can get access to efficient compliance visualization. So we start with policy design, actually. So the general development process of Rudder is to start by managing the nodes we have, because the server needs to know about the node it manages. So we'll collect information about the nodes and we'll classify them using groups, which are called groups in Rudder, which are basically a set of machines. Then we'll design the policy templates or the configuration templates we want to apply, called techniques in Rudder. We'll create instances with a particular configuration called directives, and then we'll make the link between the policies and the groups so that policies are actually applied. And that's basically the development process, and everything can be done through the same web interface. So let's have a look at nodes. So nodes are the name we give to machines that have a Rudder agent, basically. So a Rudder agent includes an inventory component and the configuration component. Inventory is mainly there for classification, so basically to create relevant groups. We're not an inventory tool. That's something we use for configuration, actually. So if we go to the Rudder web interface, here I have a demo server with several nodes. We can have a look at what Rudder knows about our nodes. So if I go to the list of managed machines, well, you can see we have information about the operating systems, the compliance information. We'll see later what it actually means. And here we have a full information about operating system and a lot of inventory things, very detailed about hardware, software, network with the MAC addresses and all this stuff that can be useful to actually create groups for our nodes. So basically groups of the nodes that are in a particular network, for example, or that have physical nodes that have a particular brand of RAID controller. I don't know. There are a lot of possible things here. So that's basically the inventory. So the agent provides an inventory to the server, and then the server can create groups based on this data. So this is for the information coming from the inventory, but we also have a way to provide information to the Rudder server for things that are not coming from the machine itself, but to give some external information. And to do so, we'll use a database that is local to each node, and each node has a key value database associated to it, where you can put any data you want, and it can later be used for a lot of different purposes. So here, for example, in my hypervisor 01, I have one property, which is TLS agent cert, and there a pass. So that allows providing information that is not coming from the node itself, but from outside, maybe a CMDB, maybe an external tool, maybe a synchronization with an external tool. So this allows getting external data into Rudder to have knowledge about your nodes. So these properties can be string or JSON objects, so you can have structured data there. And they're usable in group definition, in node search, or as configuration data, so you can put it in configuration files or anything. We'll see this later. So now we'll have a look at how we define groups, actually. So we see that we can use inventory data to define groups. So classification is done on server side, and a group is basically a search criteria over inventory data. So I said all nodes that are in this particular network subnet, in this particular subnet. So this is this kind of criteria that we'll use to build the groups. So we can give an example here. So zoom in a bit. So here in the node management, we'll go to the groups page that allows managing the groups for our Rudder server, and we can create a first group. So let's start with a CentOS 7 group, for example. So we just name it, and then we'll configure the actual criteria we want to use. So in this case, we have here the whole inventory data that is available, and we'll take the operating system name, and we'll choose CentOS here, and we can have we can add another criteria for the version. So we'll take version 7 something, and here if I search, it will display all the nodes that Rudder knows, so all the managed nodes that match this particular criteria. And so this allows us building the group. And the interesting thing is that this group content is constantly reevaluated. So if we add a new node being a CentOS 7 to our Rudder server, it will automatically enter the group. Or if the node maybe changes version, is upgraded to CentOS 8, then the node will leave the group automatically. So this allows applying things to particular categories of nodes. So let's save it. And let's add another group, this time based on maybe a node property. So we'll imagine that we want to classify our nodes based on their location. So let's say we want the nodes being in the London data center, for example. So let's create this group. We can use a property, so this key value database as a source of information. Here somewhere, properties, yes. And we'll use location equals London as criteria. So for now, nothing, but we can save it. And what I can do is go to my node list, and let's suppose our hypervisor 01 is actually in London. Then you can add location equals London here, and we'll see that our node will actually have entered the group automatically. So this allows managing dynamically the content of the group based on some external properties for the nodes. Okay, don't hesitate at any time if you have a question. Please interrupt me. It will be easier this way. Okay, so now we have groups. So we have classified our nodes. For the node management part, it's basically it. We can now move on to policy definition, which is the most interesting part for a configuration management tool, because that's how you will actually define what will be done or automated on your machines. So we use techniques which are generic policy templates. They are configurable. That's a bit like you can have in other tools like playbooks or Puppet modules or this kind of thing. That's the equivalent in Rudder. It uses basic system resources like files, services, packages, and is built from these core components. So we have two types of techniques. We have standard techniques that you will build using either the web interface or directly writing code, or we have pre-built techniques that are part of the base install of Rudder or installed through a plugin that are ready to use, but are not modifiable locally on the server. So let's have a look at the techniques coming with Rudder. So we'll go back to our web interface here, and okay. So now we're basically done with the node management part. We have our nodes with our groups, and we'll move on to the configuration policy part. So we'll go here in this directives page, and here you can see on the left there's a tree. Okay, I'll call this one. There's a tree of what are actually pre-built techniques that come with Rudder and that allow easily starting configuring base system components like packages, users, SSH daemon, cron tasks, this kind of basic system stuff, or on Windows maybe registry entries. So this kind of basic system stuff that you will likely do on a lot of systems. So they come predefined as part of the Rudder base install. For example, if I search for SSH, I will have two techniques coming with Rudder for SSH, one for authorized keys and one for the configuration of the SSH server. And if I create a new instance of this technique, I can provide specific parameters that I want to apply. So these are the pre-built techniques that come with Rudder and that you can configure using a web form like this. So you can adjust the different parameters, and then it's applicable to your systems. So these are the pre-built techniques. But for now, we want to install an OS query daemon on the node. So OS query is a program that allows querying various information about our systems that can be useful, and that can also be integrated with Rudder using a specific method we may see later. So in this case, we don't have a pre-built technique to install OS query, so we'll have to build one basically. But you'll see it's really easy, and Rudder has everything to help you create it. So let's go to the interface that will allow building your own techniques. So it's in the techniques page. And so this interface is the technique editor that allows creating or modifying techniques. So I'll just show you how it works. So on the left, you have the list of currently defined techniques, basically. And here you have your the workspace where you will configure what they actually does. And in the right part, here you have access to the building blocks. So basically, here is the list of techniques, here is the content of a technique, and here are all the building blocks that we'll use to build the technique. So if I take, for example, one of the techniques that are already defined, you can see we have here several what are called generic methods that are actually coming from the building blocks here, and they are basically the content of the technique. So a technique has a name and a set of building blocks that are called methods in Rudder, generic methods. Okay, so that's the general idea. You will create a technique that is somewhere you can put building blocks, link these building blocks, and then you're able to apply it to your nodes. So a generic method is a building block for a technique. That's an elementary state of the system. So that means ensure that the service is started, ensure that the package is installed in a given version, ensure that a specific file has a specific owner or a specific group. They are as much as possible independent from the underlying system. So you can use, in this case, we'll use a package present method to ensure our OS query package is installed. And this method will take care of choosing the right method to install the package depending on the system. So if we are on a RHEL or CentOS system, it will use UM. If we're on a Debian, it will use apt and so on. So these methods try to abstract as much as possible what the specificities of the underlying operating systems are. And they are generally a state and not an action. So that means you do not configure a list of steps like in a script, but you configure a list of states you want ensured. So that's an important point. Okay. Some specific actions do not define a state, like restarting a service, executing a command, and these require specific handling. We'll show you how it can be used. Okay, so we'll now start creating our OS query technique. So we'll go back to the technique list, and we'll use the create button here. Now we can give it a name. I'll just OS query here. Here we can have a description. So this can be used for later documentation. Install query. So it would be more complete, but that's the basic of it. And now we can start adding methods. So a first easy method to add is to ensure the package is present. So here I can go to the package category and select the package present method, and it will be added on the left part, which is the list of currently used methods. And now we can see we're missing some parameters because we'll need to configure this method. So I can click here on the pen icon, and then I have access to a formula that allows defining what we exactly want to do. So in this case, we want the name of the package to install, so OS query, and all other fields can be left empty because they have sensible default values. Basically, I won't get into details, but a lot of fields have default values that make sense. In this case, that means install any version on the right architecture on the default provider. So, and now we have our OS query installation method. We can save the technique, and it's already usable as a piece of configuration. It's not enough for a full configuration, but that's already something that's already usable. So if we go back to our directives page, we can see at the end of the page that the OS query technique has appeared and is directly usable, like the pre-built techniques you've seen before. So that's a very simple method, but in our case, for our OS query technique, we want to make it configurable. So basically, in a lot of cases, there are different, you have different machines with different groups, and they may need different values for some variables. The way you can do this is to provide parameters for your technique, so the technique becomes configurable, and then you'll have to provide parameters when creating an instance of this technique. So in our case, we want to configure a client TLS certificate for our OS query daemon. So we want to keep these two variables in the OS query configuration variables in our technique. So the technique won't know precise values, but will be configurable. So how we do this is to use the parameters tab here, and adding parameters. So TLS client cert and TLS client key. That's what we want. Okay, I can save it. And now if I go back to my directives page, you will see that these two parameters have appeared as configurable fields. So now when we instantiate the OS query technique, we will have to provide a path for the client certificate and a path for the client key, and then we can have different values on different parts of the infrastructure using the same base technique. So that's how techniques are generic, using different parameters values. Okay, so we can go back to our technique. So now we have defined our parameters, but we actually want to use it. So we have several options here. We could edit file, we could enforce the content of the file, but what we'll do here is something that is quite that happens quite often when configuring applications with maybe complex configuration files, is to use templating for the configuration file. So this is the safest option, because editing files is always a nightmare, basically. So if you can use templating, then use templating. So Rudder 6 now allows attaching a file directly to your technique. So that allows attaching our template directly to the technique. So we have in each technique a file manager that will allow uploading files to the technique, attaching files to the technique, and then you can use it from the content of the technique. So let's here have a look. So I have prepared the beginning of what the template will look like. So basically that's the configuration file for SQuery. It's JSON configuration file. And the idea is that we want to get the value of our parameters in these fields, so as TLS client cert and TLS client key. So we want to take the value of the parameters and put them inside of the configuration file. So here we'll use templating to do so. And we'll actually, the main option for templating in Rudder is to use the mustache syntax. So you have the details in the Rudder cheat sheet or in the Rudder documentation. So basically, we'll use curly braces as marker for substitution, and then vars.osQuery, because that's the name of our technique. You can see it here in the technique ID. So that's basically how it works, how we can access variables from a given technique. And then the name of the parameter, so in our case, TLS client cert. And then we'll do the same here. With the client key parameter. Okay, so now our template looks like something that can be correct. So we'll save it. And we can directly upload it as a resource attached to our technique. So I'll just select the file and upload it. And here then I can review it or edit it afterwards. Okay, so that's good. So now we have our resource attached. We have our configuration file. So what we want to do is to do the actual templating. That means replacing the configuration file on our managed machines by the content of the variables. So we'll use a templating method. So here we use the mustache template. So we can look for mustache, and we'll take the mustache templating method here. So the mustache templating takes two parameters. One is the template file, and the other is the destination. So basically, we'll take the template file, replace the variables inside, and put it in the destination, like you could do with a lot of other automation tools. So here you have the path to use as a source, because that's the path of the resource we just uploaded. So we'll use it as a source. And for destination, we'll use the OS query configuration file destination, which is actually etc os query.com. So that's okay. We should have everything we need. And we can save the technique. So that's the basic of technique configuration in Rudder. There's a last interesting thing about the technique editor that will be useful in a lot of cases. That's the ability to execute generic methods depending on a specific context. That means that there are a lot of there are some methods we don't want to execute at each agent execution. For example, restarting a service. We don't want to restart the service at every execution, but we want to only do it in specific cases. And that's that's how we use conditions. So in our case, we want to restart the OS query D service in some cases, well, mainly when we updated the configuration file. So we'll take the service restart method, service restart here. Here we put the daemon name, OS query D. If we just save it like that, that means the service will be restarted at every agent run. So by default, every 5 minutes. That's obviously not what we want. So what we'll do is to use a condition. So if you go into the result conditions of the mustache templating method, you can see 3 conditions that can be defined. A condition will be defined for each generic method depending on the status after execution. So if the state of the system was already correct, it will define the success class, the success condition. If the system has been repaired, it will define the repaired condition. And if it could not fix the system, then the error will be defined. So that allows us having different behaviors depending on what has been done in previous steps of the technique. So in this case, our condition is the repaired condition because we want to do something when the configuration file is repaired. And we'll use it here as a condition for the restart. And that means the restart will only be executed if we if we have an edition just before of the OS query configuration file. Okay. So that's for the restart. So that's basically what the technique editor is about, having parameters, having resources, and maybe having some templating and conditions for methods. There's nothing more complex here, and you can do a lot of things with these simple tools. So yes, the technique resources allow basically encapsulating everything, attaching files to the techniques to make them totally independent from the rest of the system. People who have already used Rudder in previous versions know that to copy files, you previously needed to put them in a shared file, and that was a bit of a problem because it created a dependency outside of the technique, which was a bit harder to manage. And the last parameter in the technique are the report components. So if I get back to my technique, you can see here we have a report component. That's basically the description of what it does. So by default, it takes the name of the method. But in some cases, when you have a lot of components in a technique, that may not be readable, so you can modify them. This will allow easier future reading of the technique, and it will also be useful for compliance. So here it could be OS query configuration file or something. This will make, yeah, like this. Okay, so this will make reading the technique easier because we know actually what it is and not just the type of action we did. Okay, so now we have defined a technique that should be applicable, and we'll create an instance of it. So we'll go back to the list of available technique, and we'll create an instance. So the only thing we'll have to do is to provide the values for the parameters of our technique. So in this case, maybe tcssl client dots. Yeah, let's provide sample values key, for example, and then we can save it, and this will become an applicable policy. So a policy you can apply to a node. To do so, we will use rules, which are the last item we have not seen yet. So we'll go to the rules page, and the rules are the highest level items in Rudder, and they make the link between the groups and the policies, so the directives. So in our case, we can create a new rule named example OS query agent setup, for example. In general, you want to group policies by business logic and rules, so that may be baseline policy or something. In our case, we'll just make it for the example. So here we can look for our directive. So I'll select it, and I'll select a group to apply it on. So let's take all our Center 7 machines, and now we can save it. And from the moment I click on update, it will apply the configuration to the nodes. So starting from now, the nodes will automatically start applying the configuration. And basically within 5 minutes, it will have been applied on all our managed systems. So we'll trigger it just for make it easier to read. I'll disable another directive here because we may confuse them. Okay. So now what we can do is to go directly on the node to see what actually happens locally. So if I connect to one of my nodes, hypervisor 01, for example, the one we used before, I can use the Rudder command to apply the configuration manually. It would have been done automatically, but we can do it manually also. So we can use the Rudder agent run command that will trigger a run with a -u option that also indicates the agent we want to fetch the latest version of the policies before applying it. So this will apply the different components. So, well, maybe, but I don't think I'll manage to make it both readable and yeah. There are a lot of components because we'll see later, but there's a big rule, which is the CIS guidelines that is applied and has a lot of components, so that explains the size of the output. But then we can see the last steps are actually our OS query technique. So the package was already present, but we see that we actually modified the configuration and restarted the service because we modified the configuration. And if I rerun it now, it should not do anything and just report compliant. Oh, Yum is doing something in the background. Oh, too bad. Well, let's go back to the web interface. Yum will. Okay, it's done. Yes. A lot of components because of CIS and yes, CIS, 400 components or something like this. Okay, so here you can see everything is compliant. So the package is compliant. the configuration is compliant, and for the service restart, we have a specific and not applicable state, which means the conditions were not present to execute it, so we did nothing. But that's correct, because it's an expected case. And if we go back to the web interface, well, we can start by the list of the nodes. So if I go back to the hypervisor 01, we can go to the compliance tab here, and we can see the state of our different rules. And if I go to the OS query agent setup, well, you can see everything is correct. And we have reports about what actually the current state of the system. And you have the same kind of a visualization, but by rule. So if you want to see on all our nodes, what is the state of the OS query rule, you can see it's applied on half of the nodes, and it's still pending on the other half because the agent, which runs automatically every 5 minutes, hasn't run yet, basically. Okay. So now we can have a look at the CIS rule. So that's a rule that comes with from a plugin, actually. So I just installed the plugin on the server before starting, and I just applied it to our nodes. So the plugin provides 2 rules, one for Debian 9, one for Red Hat derivatives. And so here you can see the content, the actual content of the CIS rule with all the directives that are applied. And we can drill down to see the actual problems in the policy. So if I go back, for example, in my hypervisor 01, I can see that there's a problem while trying to install a specific package. So this provides a visualization of the current state on all of the nodes of our CIS security guideline. So you can see it's not this good because I actually only applied it in audit mode and not in enforce mode. So what does that mean? That means Rudder has 2 modes for each policy file, for each policy. So a policy can be either in audit or enforce mode. Enforce means that the agent will make the configurations. Audit means it will just assess the state and report the differences if there are any. Okay, we will skip this. What we can do now is to add a new node. So let's imagine we installed a new machine. We installed the Rudder agent on it, and we just configured its server. It will appear in the new nodes page. And now you can see we have a Prometheus server here that has appeared. And I can see the details. And now I can either refuse or accept it. So refuse means this Rudder server won't manage the node, but accept means select it. Accept means the node will start being managed by Rudder. Okay, so now it's accepted. So if I go back to the node list, we can see it has appeared here. And it will automatically get the configuration that match its group. So it's in CentOS 7 machine, so it will enter the CentOS 7 group automatically. Okay. Everything we do in the Rudder server is actually traced. So we can go to the event logs page, and here we can see everything we did during this demo. For example, we modified a group here, and we can see, oh no, we didn't modify the group. Rudder modified the group, and that's because our new node entered the CentOS 7 group. So it has been traced. We know when it happened, who did it, and what actually happened. So I can go back to something I actually did, like modify the OS query directive, or adding the OS query rule. So everything anyone or any API accounts does in Rudder is traced in this interface. So you can review and have access to everything that happens. We have a lot of integrations. We don't want to add too many different features to Rudder. We want to focus on what we do best, so configuration management, configuration auditing, and reporting and compliance. And so for example, monitoring integration or integration with other automation tools that are more orchestration oriented, like Rundeck or maybe Ansible. We provide integrations that allows sharing information between Rudder and these tools using Rudder's API to allow an easy integration of those. And we also have plugins for specific features like PDF exports, notifications, stuff like this. And we have a full API, so everything we did in the web interface is also available through the Rudder API. So you could use it to integrate it to anything, basically. Okay, so thank you. Tomorrow we have a more detailed workshop that will have a hands-on part and will allow you to manipulate a bit the Rudder server yourself and learn how to do things with Rudder. You can go to docs.rudder.io for the whole documentation. We have a getting started guide and we have various documentations. And don't hesitate to come to our chat rooms, either on chat.rudder.io or on IRC if you prefer, and we'll help you. And so don't hesitate to ask questions there. Thank you.